So ready and go. So a pair of circles tucked into a corner, quite a common type of question. Larger circle has got radius capital R and the smaller one has radius small r. Two obvious triangles. Large circle, radius r, and small circle, radius small r. Right-angled corner, by symmetry that means that's a 45-degree triangle, both right-angled of course, radius meeting tangent. So you've got two similar triangles. Not going to use that fact, we use the fact that they are similar triangles, but they're both similar to your standard 45 triangle, which goes 1, 1, root 2. So even though the question asks what's the ratio of r upon r, which leads you straight into thinking, well, I'll just put this triangle over that triangle. I'm not going to use them directly, I'm going to use them in relation to this 1, 1, root 2 triangle, just by saying what are the two ways I can get the length of this hypotenuse. Because simply from this triangle, that large hypotenuse with r there and r there will be root 2 times r, but also just by adding up the bits and pieces, if that's the centre, then up to this point that's the radius of the larger circle. Again, from its centre, that's the radius of the smaller circle. And then from this no.23 triangle here, the same as this part will be root 2 times r. I'll just put it down again. For the little triangle, small r, that'll be using the ratio root 2 times small r. So rather than doing r over r, I'll just say what are the two ways of getting this diagonal here? Well, you've got this. Either in one go, it's root 2 times capital R, or in its bits and pieces, it's an r plus a little r plus root 2 times r. Now, take this over here, so that'll be one of them short of that, so that'll be root 2 minus 1 lots of r. Here I've got one extra one, so that'll be 1 plus root 2, or maybe I'll put it as root 2 plus 1 lots of r. Take that across and there's your answer. R over r, the required ratio will be root 2 plus 1 over root 2 minus 1. Of course the answer isn't given that way, so I'll just make sure that I rationalise the denominator by multiplying the top and the bottom, numerator and denominator, by the conjugate, which will be root 2 plus 1, so the top will turn into root 2 plus 1 squared. And of course, in doing that, in choosing that, the bottom then becomes the difference of two squares. So that squared is 2 and that squared is 1. Well, 2 take away 1 is 1, so that's gone, so it's just square the top. Squaring the top would be square the first, 2, square the second, 1, plus twice the product, 2 times 1 times root 2. And there you are, 3 plus 2 root 2.